화면이 한꺼번에 안 보여서.
뭐 알아서 하세요. 나한테 물어보지. 볼 사람 시청자를 위해서 해야지.
오늘 돌아오고
시청자를 위해서 해야지. Alright. So this is the schedule. I changed some of them because there will be no class on next week. No, on two weeks time. Right? Next week there is 2 classes. But I moved the 6 invited seminar to Wednesday. This is Wednesday or Thursday schedule. And also there will be another extra morning class on 21. This is Tuesday. So then change accordingly. So today I will cover chapter 1, right? Together with Soonhung. So chapter 3 will be covered this week, and then next week we'll have a chapter 4. Question on schedule. No. Then we go on to chapter 3 then. Right. So chapter 3 is about representation. How can you represent design and also knowledge inside computer? Right. This is chapter 3 of the book. And chapter 3 is made of representation of design itself. And then section 2 is about relationship. Relationship is kind of knowledge. And then section 3 is intention, design intention, and finally design knowledge. And then the final section is about translation between 2 different representation of knowledge, model of knowledge. So if you want to use different commercial system, so TensorFlow, moving from TensorFlow to another cafe tool, right? Then you need to convert data. That is very similar to a language translation. Anyway, translation. You need a translation. But this is about translation. Right. So design is to generate a description. Description means kind of model or drawing. In response to desired performance is design requirement. Desired performance. Right? I want to make a smartphone for Indian ladies. Right? That is desired performance of that smartphone, which can be loved by Indian young ladies. Description itself is the drawing or CAD model should be translated into physical reality in the final stage. So once you design a product, that output can be a drawing or CAD model, right? Or a book. And then that should be used for real manufacturing or construction. Right? So reality. That is another step. So design and manufacturing is separate. But that should be in your mind when you're designing something. Manufacturing should be considered. Designers, sometimes they do not such a consideration. When I was in the United States a long time ago, Ford Mustang is a brand name inside the Ford Motor Company. Still working, right? Mustang. At that time, the one brand has a very special shape in that on the hood of engine compartment, there is a birch. Usually the hood is fine shape, right? Smooth, fine shape. But in center of that, there's a birch, round cylinder something, right? Because of the engine is too big. inside the engine room, right? So the engine is protrude above the smooth line, so that they must have a special shape of hood like this. So I guess that there has been some conflict between engine department and style department. That is my guess. But anyway, the designer should think about that kind of thing, manufacturing something. That was also famous because of that special shape. You can find from Google image. It's about 30 years ago. Designers use information about elements. Elements can be a part of vocabulary and the relationship between them, and also properties and classes. So brochures, catalog, parts catalog is very important for designers. So in old days, the experienced designers should have his own box of catalogs. And collection of catalog is very important for him because he should choose among them. Nowadays, because of the internet and Google, we don't need anymore. Right? You can find out better one around the world, right? So it's easier. But still, the option is still growing than 10 years ago. So its complexity is increasing. But anyway, so you need properties of the parts and classes. Designs and design goals, target, and knowledge have been represented. Represented means externalized in terms of graphical or texture or symbols and drawings or CAD model inside computer. Not coming from your brain. Right? You have a good idea, but you should externalize, represent to the manufacturers and buyers. So this is a nice picture of drawing. So this 3D drawing. Right? It was not easy in long time ago, but nowadays it's easy because of the computer. But without computer, how can you draw such a picture? Right? It looks fine, but drawing is very difficult. Three representation issues, difficulties. How can we should represent design and knowledge. And how designs itself and vocabularies, the parts can be represented in terms of equation, in terms of pictures, in terms of Word file or Excel sheet. How can you represent? Right? And there is object and properties and relationships and inheritances. So design goal, also the design goal itself, not only design itself or design goal should be represented together. Because designers start from a design goal. I want to design a smartphone for Indian ladies. That is a design goal, right? It's simple sentence, but that is not enough. You need to elaborate more on this short sentence. Or for the contract something. I want to build my nice home. And then I should find out, first I should find out money, right? And then I should find out the contractor who can build, right? And then we need to have a contract signed. So the contract should be detailed enough, right? Otherwise, there can be a big problem after months, right? The money side, the schedule side, and items, important items, should be well documented. That can be a representation of design goal, right? Description of goals is partial, incomplete, and abstract. At the beginning, it is very short. Right? I want to build my nice home. Starting from there, and then we need to elaborate. until contract signed. Right? For my home, it's relatively simple, but I want to build a big building, right? 100-story floors. Right? Then it can be a big project. Then the contract with the constructor, contract signing can be a big work. Right? We need the books of drawings, the books of documentation. And at the beginning, it is very simple, but it should be design transformation starting from partial description. Right? Partial description means I want to develop, design a smartphone for Indian ladies. That is very simple and partial description. Into complete description can be a CAD model of smartphone. There is a special category of softwares called, or technologies, requirement management system and goal-based design. That is relatively new terminology that handling the design requirements or design goals. So this is a software name, commercial software name. You can buy this one to handle your design requirements. Say, I saw a case in nuclear power plant industry. And they use that kind of software. This is expensive software, but they need such one. Knowledge about design, okay, intuitive knowledge, internet knowledge. We already see this. Representing designs, right? Object and relation and properties and classes and instances. So we already see that object is made of into fact, and fact is made of knowledge, and knowledge and control. Right? So there is some relationship, and also properties and classes and instances are coming from terminology coming from object-oriented program. So there is issues and relations and properties and class instances. Object and relation, property, class, hierarchies. So smartphone can be made of, say, how many parts? 30? 100? And there is a hierarchy. How about car? Usually people are saying there are 20,000 parts inside the car. But depending on how do you divide, right? I already told you once that this is how can I say, the purchase order level or handling level, identification level inside that company. Because inside Ford company, motor, electric motor is a one single item, right? One ID. Because they purchase it from another company. They do not make electric motors themselves. Right? So it's a single item, one part. And then that kind of parts is 20,000 per car, right? So handling, what can I say, item, something. But inside the company of making that generator or motor, there is not single item. Yeah? This is made of parts, right? 100 parts maybe, or 50 parts. Right? So that kind of thing is, you can say, hierarchies. So once I draw the tiers in like this, supply chain management. Right? So we said this is tier 1, tier 2. So this is a Ford, right? Then electric motor is one single item. Right? No. Tier 1 make say they are subassembly something like air conditioning. Air conditioning module. Module is supplied by tier 1. And tier 1 by electric motor. From the electric motor manufacturer. And so there is so many hierarchies. And level of detail too, also, right? And relationship, this is from coming from architect or construction, civil engineering, spatial and topological relationship. Right? It's important for them. And properties, there are geometrical shape properties, and there is a functional properties. Right? It is hard, what is soft. This is shining. There are so many functional properties. Smooth, and classes and instances coming from object-oriented programming. So we saw this one in chapter 2, that the relationship between object is fact, and relationship between fact is knowledge, and relationship with knowledge is control. Let's see. So layers and hierarchies and relations are there. Object and properties. Properties in terms of attributes and values in this book. So color is a property, and that value can be read. Properties as object. So properties can be handled or represented as an object. So object is atom, right? Atomic element inside in our knowledge-based system. So entity of any physical entity can be object, right? But also their property can be handled or represented as an object. So there can be a recursion. Right? Recursion is higher. Properties of properties, right? Properties of property. Say property grouping or property group color groupings can be also used. So that is similar to object-oriented programming. And then programming says there is a class and generalization of specialization. So in this hierarchy, object-oriented programming, right, it's very similar to assembly, right? Assembly. So this class hierarchy. It said this is a class in object-oriented programming. Superclass, or we say subclass, right? Subclass. Downwards, and then finally we find out the instance. In leaf node can be an instance. So in this direction we say generalization. Generalize, and this is specialization. Same as this. Very similar. In manufacturing, right? In manufacturing hierarchy, assembly, right? Physical assembly, very similar to object-oriented programming in software programming language. Right? Specialization, or generalization. Right? We'll see more. Right. This is samples. Right? In food, this is class, superclass of food. Includes or subcategory can be a vegetable and fruit can be specialized into apple or berry, and apple and pear, and this is more. This can be a property. And then here, transportation class. There is a property like a maker, date, nation, country, and then subclasses like a bus and car and plane, airplane and ship, right? And properties like a seat and field type, transmission, engine size. Or in this way, or in this way, you can find out. question? Question. Recursion, combination. So complexity, coming from relations between properties. There is a relation between parts, physical parts, and also there is a relation between properties itself. So yellow is brighter than gray, right? The relationship. And classes of properties. Red and green belongs to colors. So color is higher level and includes subclasses like red and green. Subclasses of colors. Right? And also there is a classes of relations. Right? Classes of relations. Bigger than and smaller than is a class of transitivity relations. So the complexity is coming. Right? Properties has their classes, hierarchy. Physical entities also have hierarchies. And relations also have hierarchies. Then we are using a combination of them. So complexity arises up. Right. Representational issues. In old days, conventional method we use in terms of design, right? Knowledge-based design. In terms of design, traditionally we use drawings. Right? Drawings is made of graphical symbols and textual levels. We saw the bicycle drawing, right? But that is not traditional one, actually. Right? It's a drawing, but very modern drawings, because it is 3D drawing. Human being can interpret the graphic symbols and robots. So drawing, in old days drawings, you hand it over to manufacturers, right? Floor. And then human engineers in the machine shop, they should read that drawing and understand what is intended there. That drawing is created by designers, right? Handed over to technicians in the floor, right? But they should understand what is inside drawing, and then they can manufacture the real product. Right? But the problem is even human cannot understand that drawing. The baby, young student. So you need training for understand what is inside drawing, right? And also experience. Right? How about robot? Nowadays robots are very clever, including AlphaGo, AI, right? But still, human is better in manufacturing. But I want to make unmanned manufacturing facility in the future. So how can you train them, the robots? Also, training is important. Also, you need to provide the robot more information than paper drawing. More information is important. That's why we are using 3D CAD model. 3D CAD model, you can say that the file size is bigger than AutoCAD drawing, right? That means that contains more information. That helps robots to do their work automatically. In a knowledge-based design system, we must make explicit information from implicit in the designer's drawing. So the drawing, 2D drawing, in old days, 2D drawing, that drawing contains a lot of information. But technicians have educated to understand, to interpret the information inside drawing. That is implicit in a drawing. So you need some kind of AI for robots to interpret the implicit information inside drawing. interpretive knowledge should be provided to robots. Shows a level of details. As a picture, right? Coming from, so starting from right? So abstract level, very, very simple information. How many bytes you need to represent this one inside computer, right? Comparing to this one. Right? Resolution, number of information, bits, right? Or let's say level of detail, all in this way. Right? The simplest one or original one. You can simplify these models to reduce file size or increase the performance of graphics. Hierarchies of abstraction. So you need to think about hierarchies of abstraction, level of detail. Multiple representation of the same object. Right? Multiple representation of the same object. Those 5 faces are representing same people, same human, right? One single human person, right? But there are multiple different representation of one single person with different level of details. Well, I'm saying that there are multiple copies there. Multiple copies of CAD files there. Why? We need them. Right? Why we need multiple representation, even at a cost of redundancies. There are redundancies, but we need them. And then redundancy creates inconsistency problems sometimes. Right? But we need them. Problem with the redundancy, inconsistencies. They create problems. Say, I changed my design because of some reason, but the manufacturers, technicians are manufacturing, using old drawing. Right? As a designer, I changed my design, but that information, the change, did not propagate well. Change propagation is important, especially for complex system like a nuclear power plant, airplane, right? Because it's a complex and big system. There are so many people are involved in that system creation. Designers, also many designers. Hundreds of are them working together to create single nuclear power plant. Right? And also construction at site, there are so many people are working together. So mismatch can be higher, the probability of mismatch. So we need more softwares, systems, or terminology and technology. Okay. Right, representation, we already see this one. Right. And then sample of level of detail. This is, what is this? Logic diagram. This can be a circuit design. Circuit design of, say, RAM or ROM, memory, or chip, or any. And then the level of detail starting from just a formal specification means just a sentence, wording, not graphics, no graphics. But starting from floor plan and then logic diagram and layout. Layout can be very detailed in terms of sizing. The millimeter size, thickness should be shown in layout. This is a sample. When I visit a Google office last year, there is some kind of this big wall. And everybody, like me, stand over there and then find out my home. Everybody can find his home. Not everybody, but most of them. Right? And then zooming in, right? Zooming in. So that my home is around here, right? Zooming in. And finally, I can find picture of my home. Very interesting, right? So level of detail is there. Right, it's like this one. Everybody is. And set operation, Boolean operation is also another kind of layers, and shaping and handling. And object relations, descriptive relation. There's a relationship. There are different relationships, structural relationship, hierarchical relationship. And object and relation, we already see that fact is made of object and their relations. And fact in mathematical predicate calculus, there's a mathematical logic and object relation and semantic. Prolog, I already told you once. Prolog is a programming language for AI, and still working. They are coming from this mathematical logic. Programming logic, right? Logic, mathematical logic. Alright, so basic components of semantic network. So it's a network of, say, any a map or philosophy, and this is final slide coming from here. This is example coming from floor plan of apartment. House. So they want to say this can be a living room, can be a kitchen, can be a bathroom and sleeping room, bedroom, something like that. And they want to make out relationship between rooms, so that they want to make a door between them or pathway, right? So that each node represents a room, space, and then the line between them is a relationship between room, right? Using that network. It is a network. Only this one is network, right? Or this one. Right? So after creating a simple relationship network, you can put some ideas and handling, operating, manipulating them to define better floor plan. Okay. Question? No question. And then Sunjo. Right?